Hello everyone. This video is going to be about this. It's a full adder I've made using Create Power Grid, which is an add-on for the Create mod that adds lots of electrical circuitry type stuff. With it you can use transistors and resistors and other basic components to make logic gates, and the mod will simulate these circuits in real time so you can interact with them and observe their outputs. You might expect then that we can do some serious digital logic with this. And although I've seen people make logic gates with this mod using transistors and relays, I've not seen anyone do any serious computational logic with it. So this hopefully will be my contribution to show that that is possible, and it's not too hard to pull off. I'll show you this single full adder first, then I'll show you these four that I've wired up to give me a 4-bit adder, and then I'll talk a little bit about the internals of these devices and some of the pitfalls, I guess, in constructing them. So first off, here is your full adder. It runs on 5 volts, and the output here is just using 12 volts to drive these bulbs. We have 3 inputs, carry in, some first, some second, some out here, and carry out here. If I turn any one of the inputs on, we get a 1 for the sum. If I turn any 2 on, we get 0 for the sum and 1 for the carry. Any 2 inputs works. If I turn all 3 on, we get both sum out and carry out. So that's definitely the truth table for a full adder. Test passed. Now the test is whether we can wire them up to produce a proper, however many bits wide adder. I've done this in a slightly less compact way than you could in principle, because I've chosen to space things out a bit. Again, 5 volt TTL supply for the logic, 12 volt supply for the bulbs. We have 2 4-bit numbers, one along the bottom here, one along the next row up, and then we've got a carry in on this little switch. So if I put in, for example, 3 in binary, and I add 1 to that, it carries all the way up to 4. And we can see that that carry functionality works the whole way along, as as it has to. It'd be a pretty rubbish full adder if it didn't do that. So yeah, we can add 2 4-bit numbers or 2 8-bit numbers if you can be bothered to wire it up ad infinitum. I've done it about as compact as I can per full adder. It's only 2 of these tiles. I'd be interested to see if anyone can beat that. I mean, I don't think you can get it in 1 tile, but you can probably beat the slightly janky layout that I've done here that requires you to string some wires between them. But overall, I'm pretty pleased with it. So internally, what's going on here is that the first plate has the 2 XOR gates of a classic full adder diagram, and the second plate has 3 NAND gates, which gives you the same functionality as the lower half of a classic full adder diagram, where you've got 2 AND gates and an OR gate. Inside, it's a bit of a mess because I've done what I always do when I'm prototyping circuits in real life as well. I make these fantastically compact layouts, and then inevitably I have to tweak something, and I want to pull my skull out through my eyeballs. It's worked out here though. So we've got 5 transistors per XOR gate, 1 on the top, 1 on the bottom. Those are run through those little links you can see there to this board, along with copies of these 3 inputs, and obviously power and ground. You've got 1 NAND gate here, 1 NAND gate here, 1 NAND gate here. Those drive a bulb through these Darlington transistor pairs, so very little current is drawn from the output of these to shift quite a lot of current through those bulbs. You have to be a little bit careful when you're building circuits like this that the result is stable. Some of these resistors shouldn't actually need to be here, but if you don't include them, you get very strange results. I'll show you with this slightly contrived example here. This is a reproduction of a 741 op-amp. The internal circuit is on the wiki page for the 741 op-amp, and this has currently a 30 volt supply and 2 15 volt inputs. This is on. If I choose my points carefully and I stick my multimeter down this crack, we read more than half a kilovolt for some reason. No matter how badly I have messed up building this circuit, there is no way that it should be able to produce more than 500 volts from these inputs. So if you're doing anything complicated, any circuits that involve lots of kind of loops or analog voltages, it's difficult, I think, to make them behave the way you would expect, because the solver, whatever circuit simulator is in this mod, is not numerically stable under a lot of circumstances. But for digital logic like this, it's not too bad. I was quite surprised that I was able to wire 4 of these up and not experience sudden inexplicable instability. But there you are. It gives me hope that with some good ideas for how to do like instruction decoding and sequencing, and an idea for how you would store data in some kind of memory, it gives me hope that you could connect all of those up to produce some sort of functional computational machine without too much going wrong. So that would be nice to see. But for now, this is all I've got. Thank you for watching. Have fun.